10,000 diamonds. One trophy.
And every single stone was grown inside a reactor from methane gas and graphite powder. Lab-grown diamonds are now chemically identical to mined stones, atom for atom, with certainty. Coating the FIFA World Cup trophy required solving a problem no jeweler had faced before. How do you laser cut 10,000 stones to fit a curved, irregular surface without losing half your material to waste? The answer was a micro-laser scrap recovery system, a machine that reclaims and reseeds failed cuts back into the growth reactor and nothing is wasted. A $40 million concept trophy, and a process that could permanently replace mined diamonds in high-precision luxury manufacturing.
In the next 8 minutes, I will walk through the exact 4-stage synthesis process, start to finish, with clarity and confidence.
It starts here at a natural gas processing facility in Texas, with grounded authority.
Methane, the same gas you might use to heat your home, is the starting point for every diamond you saw on that trophy. Graphite powder, the same material inside your pencil, arrives from a synthesis plant in Ohio. Every batch is tested, and if the purity is not 99.999%, it does not enter the growth chamber with absolute authority.
2 ingredients, 1 transformation. This is carbon alchemy.
This is graphite, and this is diamond, with the same element but completely different worlds. Over the next 6 minutes, you will watch both become one 4-stage process, and this has created 10,000 diamonds.
Methane forms deep underground from ancient organic matter, compressed by millions of years of heat and pressure.
From wells across the Permian Basin, methane flows upward through steel and valve, ready for its journey.
Through 300 miles of pipeline, and the gas travels to a processing plant, where methane is separated from everything else. Inside this distillation tower, methane is purified to 99%, stripping away ethane, propane, and everything that is not carbon and hydrogen. Pure methane, CH4, one carbon atom bonded to 4 hydrogen atoms, is the simplest hydrocarbon and the perfect diamond precursor. Methane is compressed into high-pressure cylinders and loaded onto trucks, with the destination being the diamond growth facility. Clear. The journey from Texas gas field to diamond reactor takes 8 hours, and every cylinder is tracked by GPS, with every digits.
Meanwhile, in Ohio, graphite powder is synthesized from petroleum coke to extreme temperatures.
The synthesized graphite is ground to powder finer than flour, with particles measured in microns, and this fineness is critical for the diamond growth process with technical appreciation.
The methane and the graphite have both arrived, and now the real work begins.
I am a material scientist, and for the next few minutes, I am taking you inside a process that most people never get to see. 4 stages: seed preparation, plasma growth, laser cutting, and scrap recovery, and this is how you grow 10.
Every lab-grown diamond starts with a seed, a thin slice of existing diamond that acts as a template for carbon atoms to follow with scientific precision. Any contaminant on the seed, even a single dust particle, will create defects in the growing crystal. The seed must be atomically clean. The seed is placed inside a CVD reactor for chemical vapor deposition, and this is where carbon atoms will build a diamond 1 layer at a time. The chamber seals and inside conditions are about to become more extreme than anywhere on Earth's surface. The chamber is evacuated to near vacuum, less than 1/10 of atmospheric pressure, with no air and no contaminants, just the seed remaining.
Pure methane floods the chamber, and carbon atoms, the building blocks of diamond, are now surrounding the seed.
Microwave energy ignites the methane into plasma, the 4th state of matter. The temperature at the core is over 3,000 degrees Celsius. Inside the plasma, methane molecules break apart, and carbon atoms are freed, drifting downward toward the cooler diamond seed.
Load cells. Each carbon atom bonds to the seed in the exact crystal structure of diamond, with a growth rate of about 0.1 millimeters per hour.
Hydrogen plays a critical role by temporarily bonding to the growing diamond surface, preventing graphite from forming. Then the plasma strips it away. Three weeks later, the plasma extinguishes, and where there was only a seed, there is now a diamond. The growth run is complete and the wafer looks clean. The diamond wafer is removed. It is rough, but chemically it is 100% diamond. Raman spectroscopy confirms the crystal structure is perfect with no defects and no impurities, and the diamond is ready for the next stage with a tone of confidence.
Here is the challenge. The trophy is curved and the diamond wafers are flat. So to cover a curved surface with 10,000 stones,
A 5-axis micro laser cutter can cut diamond with accuracy measured in microns thinner than a human hair.
The laser does not cut but vaporizes, and diamond turns directly from solid to gas along the cut line, with no physical blade ever touching the stone. The cut is curved in 3 dimensions, matching the trophy exact contour, and when placed it sits flush, with no gaps and no edges catching light wrong. Traditional diamond cutting loses up to 50% of the original material, and for 10,000 stones that is thousands of carats and millions of dollars turned to dust. Every fragment is collected and sorted with nothing swept away and nothing discarded, as the scrap recovery system treats diamond dust as pure carbon that can grow again. 10,000 diamonds, each one cut to a unique shape, and each one grown from the same methane and graphite, with each one perfect. Each stone is set by hand pressed into micro channels cut into the gold body, with no adhesive and pure mechanical lock. When light hits 10,000 diamonds on a single curved surface, and the effect is something no mined diamond trophy has ever achieved. All 10,000 with 0 defects. The final inspection checks all 10,000 diamonds for alignment setting and clarity, with the standard being 0 defects.
The $40 million concept trophy is complete, grown, cut, and set without mining a single stone from the earth.
this is a World Cup trophy concept unlike any before it, with every diamond grown and every atom accounted for, establishing a new standard for luxury manufacturing.
This process does not end with one trophy, and it proves that lab-grown diamonds can replace mined stones in This represents a new era of synthetic perfection. Atom for atom, identical, but grown, not mined.
Every frame in this video is handcrafted from concept to final edit. A real human guides every step using AI tools. All content is original and follows YouTube 2026 monetization rules.